Okay, so this is the first video that I'm recording. Let's see how it comes out. What we are trying to solve is we are trying to solve this graph theory plan, which is graph theory 1 on Leetcode. So we have multiple days, and it's basically a selected graph problem that one must do for interview preparation. Let's tackle this first problem, which is flood fill. It's already opened here. Okay, so I'll just try to explain. It's categorized as easy. Uh, let's see how the it is. I'll just first want to make sure that every one of us understand the problem first. Okay, so we are given an image. So image is usually consists of different pixels, right? So we have zeros and ones, for example, in this scenario. It can be any other value as well. It can be, for example, you might be knowing that pixel can take in the value, for example, till 256 as well. So it can be any value, according to this problem. So let's take this example. What it says is you're given an m cross n grid where image ij represents the pixel value of the image, and you're also given three integers. So you will be given some certain cell within this grid uh, from which you have to start your flood fill. So what flood fill is meaning that, okay, given a row and column value, you have to search four directionally outwards from this certain cell, and if you find the cells adjacent to this cell which have the same value, for example, in this case, the flood fill is supposed to start from 1, comma 1. So if you go into four directional adjacent to cells of this particular cell, then what you need to see is whether, for example, this cell matches the color value or the pixel value for the original cell. If it is matching, then you should color this cell also, this cell also. In this case, it's not matching, so we will not color these two. And we need to, what coloring, by coloring it means that we need to change the value for this particular pixel. And this value is also provided to us as an input. So for example, we are providing as the color 2. So for example, what it says is go to 1 comma 1, try to see what is the value. Okay, the value is 1, and we need to change to color 2. Okay, so we change it to 2. Let me open my whiteboard as well so I can just show you. Okay, uh, let me change the pen. Okay, so we are given a 1, 1, this was also 1, 1, 1, 1, 0, 0, and 1. Okay. So we are given certain row and column value, which is in our case, first example is row is 1, column is 1, and we need to change this value to a new color. Okay. In the example given, it is 2. So if we see, yeah, so it's 2. So what the question says is, we'll just make sure that the question is very clear to us. Clarity matters, okay? So question says, okay, take this value, see if the old color, which is in this case will be 1, see if the old color is equal to new color. If it is equal, then we don't need to color this particular pixel and we can just directly return the image as provided to us. We don't need to do anything. If that is not the case, what we do is we have to look for directionally outwards from this pixel. Okay, so we will go to this value, we will go to this cell, we'll go to this cell, and we'll go to this cell. After this, see if there are any cells of matching color. So here we have to consider the old color value of 1 comma 1. Okay, if it is the case, If so, then color all these cells. And we have to do this recursively. So for example, once we color this also, we look four directionally outwards for this from this cell also. We'll look at this thing. We'll look at this also. On left, it doesn't have any element, so we don't do anything. Okay. So in the first iteration, just to show you how everything will work, in the first iteration, we will change the color value for the given RNC value, which is 1, comma 1. We'll change it to 2. So it will look something like this. In the second iteration, we will look at the adjacent members of this particular cell. So we'll go here, we'll go here, we'll go here, and we'll go here, four directionally outwards. So if any of these four cells matches the color value which of the this central cell, the old color value. So earlier it was 1. So we will see, we'll tell the code that, okay, look outwards and look for a cell which has the value 1. If it has 1, then make it 2. That's what it is trying to say. So what we'll do is in the next iteration, we'll do this thing. Okay. Now this is done. So the similar calls will be made for these two elements as well. So it's a recursive call. We have to keep filling up until we find the border scenario, or until we find a 0, or some other color. Okay, it can be -1 also. So we have to make sure that we don't color it. So if in this place it was -1, then we won't be coloring it. But let's take it forward. So in the next iteration, let's look at the neighbors of this cell. Okay, so it will be 1 and 1. So we'll color it 2. 2, 2, 2, 2, 2, 0, 1, 0, 1. So we haven't colored the adjacent member of this one. So this adjacent member of this one is 1 and 1. But this has already been colored, as you can see. So the function will return directly. We just need to color this thing. So we'll color it, and this is how the output will look. Now there are no more pending cells to be colored. If we go back, we'll see this is the output, okay? As you can see. So hopefully now the question is clear to everyone. Now we'll try to solve this problem, okay? So let's, before jumping into the code, yeah, I just want to make sure that everything is clear to us. So if we take the second example, it's a trivial example actually, where we have provided 0, 0, 0, and yeah, all zeros, everything is 0. So let's consider that example as well, okay? Let me try to open it. Okay. Um, yeah. So another example is we are given 0, 0, 0, 0, 0, 0, and old color value. So we are given 0, comma 0 as the starting point as well. So which is this cell. Old color value is given as 0. New color value is also 0. Okay. So what our program will has to do is it will try to see, okay, okay, the old color value matches the new color value. So there's nothing that needs to be done, okay? Even though it has the adjacent same color cells, but since this doesn't need to be colored, so we don't need to do any further processing. We will just return the image as it is. Okay. Now let's try to write the code, but I won't be writing the code directly. Let me just clear this out. Okay, let me make this a little bit bigger. Okay, uh, let's see what we are dealing with. So we have been given a flood fill function, and we are given image starting point and the color. Okay, so we have been given flood fill image row column as well as the new color value. Okay, and we need to return an integer array. I will not write whole thing. Okay, the first condition that we need to do is if image rc is equal to new color, we don't need to do anything. We can just return image. Okay. If that is not the case, as we discussed, we will color. Okay. We will color this value. But we before doing that, we need to store the old color value. Otherwise, we'll lose it. So int we can declare old color, and we will take in image r and c and store it. Now image rc can be changed to a new color value. Okay. Now this is done. Okay. But this is the critical point. Okay. Uh, we can return image after this processing. This is the processing step where we have to write the code, actual code, to do this processing. So let me, sorry, let me move it on the left. Yeah. So we need to write a fill function which will do all this processing for us. So we will provide image, we'll provide a certain row value, certain column value, old color, and the new color. Okay. Now, if so, these are just the exit conditions. So, for example, if at certain recursion stage, the R value or the C value goes beyond the boundaries, then we shall not do any processing. We'll just return it directly, the image. Okay. So if R is less than 0 or if R is greater than equal to, let's take the m cross n. Okay. You can just write the code accordingly, but I'll just for understanding, I am taking this. Okay. So return. Okay. Don't do anything. So the return type for this is void. Okay. Uh, if similarly for the column values, return directly. Okay. Now, what we need to do is we need to change the color. Okay. So old color value will still store. Okay. Uh, old color is equal to image rc. Okay. And so I'm just trying to solve this problem with you guys. Okay. So old color will store in this old color image rc will take and we'll store the old color, and yeah, we'll then color this particular cell. Okay. Color it new color. Now go four directionally outward. So we'll go to R minus 1, we'll go to C minus 1, C plus 1, and R plus 1. So these are usually the four directions, right? From a particular cell. So if you are at R comma C, this particular cell value will be R minus 1 comma C, this will be R C minus 1, this will be R plus 1 comma C, and this will be R C plus 1. Okay. So similarly, we'll just recursively call this particular function image r plus 1 c old color, new color, fill image r minus 1 comma c, old color, new color. Similarly, okay, we'll do the whole thing. So what we have is we have this one function, okay, and this logic we have to use here, okay. So what will so as a beginning point of this recursion, so we will call fill on our original cell that we had. So we will call it on image r comma c, old color, and new color, okay. Hopefully like that should be clear to everyone. Now let's try to code it out, okay. I'll write the same code. Let me get this rid of this thing. I'll write the code for this problem. Okay.
Okay, so now let's try the code. Okay, we'll continuously refer this thing. Okay, so we have provided image. First condition is if uh, the pixel that we need to color initially, if that is already colored with the new color, then we don't need to do anything. If the color of that matches the color value in the variable, we don't need to do anything. So what we'll do is we'll first of all write the code for this one. Okay. Uh, it says if image sr sorry or sc is equal to color return image. We don't need to color anything. Okay, we can just directly return it. Okay, yeah. Now next thing is we need to color it. If it is different, we need to color it and we need to store the old color. So we'll store the old color here. We'll call it image sr sc. Now we need to color this with the new color. Okay. For new color, we are just using whatever variable they were provided. Or for understanding, we can change this as well. Okay, we can call it new color just so that it's clear. It's not no longer confusing as such. We'll call it new color. Okay. Now what we need to do is we have colored it. Okay, but we need to fill it. Okay. Uh, Recursively need to fill the whole grid only if there is cell four directionally adjacent that matches the old color. Okay, now we'll try to implement the fill function. So we'll provide the image as it is. We'll provide the row. Let's call it R only. We'll provide column. We'll provide old color. We'll provide new color. Okay. Now we can see we just need to set the boundary condition first of all. So we'll do that. If r is less than 0 or r is greater than or equal to image.length, return. Don't need to do anything because we are already out of bounds. Uh, Similarly for the column values, uh, Okay, hopefully everything is correct. Yeah. Okay. Now we need to do the same thing. We need to store the old color value, and yeah, change to a new color value, and forward directionally we need to call this on its neighbors. Okay. For this cell's neighbor, we need to call this particular function repeatedly. Okay, so that we can recursively make use of this. I'll try to copy the whole thing, not type it out. Okay, we just need to change it to c plus 1 and this c minus 1. I think looks good. Okay, after this you can, it's optional, but you can choose to write a return statement. Okay, what is this? Expected. Okay. Doesn't seem to be a problem to me, but let's see. Okay, illegal start of expression. Hmm. Okay, it's coming because of this. Okay, now we'll make use of this fill. We will give the image, we'll provide the initial SRST values, we'll provide the old color and the new color. Okay, and just return image. Rest of the things will be taken care of by recursion. Okay, let's see if it works out. I expect some errors. Yeah. Okay, we need to debug this. If this is equal to new color. Okay, okay, so we are already providing the initial color, so we don't need to. Yeah, this is redundant. um, we just change the cell value. For example, once we have set the new color for this one, we have made this true. um, we can just go and fill its neighbor basically. uh, but we are why we are doing this again. I think this step is also not needed. So we'll fill the color, we'll go outwards, and we'll always maintain the old color, which is 1. All the cells which have 1 needs to be colored provided they are full directionally adjacent to this initial cell. Okay, so it's like a fill. Okay, I'm just trying to check if there are no issues with the code. Let's try to run it. Okay. One thing that we can have is additional condition where image R in C is already new color. Then also we can return. What is the issue? 220201. It's coloring everything. Okay, that's good. Let's go back to the initial stage. So if it is already new color, return image. Okay. SRSC values won't go outside of the limits. That's also fine. In old color we have stored. Okay. Now we try to fill it. Okay. Once we come to this, it will make it two. Okay. Let just comment this out for now. Image RC will be colored with the new value, and similarly for directional it will go. Try to color it. Okay. Yeah. Uh, if it is not equal to old value, then we shouldn't color it. That's the condition that was missing. Okay. Basically, if it is not equal, if any cell is not equal to old color, we shouldn't color it. For example, in this case, 0 is adjacent to this one, but it's a different color. Okay. It's not equal to 1, so we shouldn't color these two cells. And subsequently, all its neighbor, for example, 1 is cut off. It won't be colored at all. So yeah, let's try to run it now. Okay, it's saying accepted. Let's try to submit it. Okay, it's accepted. Okay, so if we go back again, what is the time and space complexity for this one? Okay, so space, I think we are only using two variables. Old color and new color is already provided to us. Okay, so in turn, basically, we are visiting all of these cells. Okay, to process it. In the worst case scenario, it will be visiting all of them. So for example, in this case, it is not visiting one at all because these zeros have cut it off. But in worst case scenario, it may end up filling all of this grid. So in worst case scenario, the time complexity in this case will be O of mn, okay, according to my understanding. And space complexity again, what all it is storing, okay. Let's think about space complexity. So we are at 1 comma 1 initially, okay. So we have stored the old color, okay. Now we go into the recursion, okay. uh, so on the stack it might end up creating this old color, uh, no, old color is also constant, okay. So, yeah, should be O of 1, okay, should be constant because it's not increasing with the amount of grid or amount of cells that we increase, okay. We don't have any variable that varies with m or n, okay. So space complexity for this code should be O of 1, and the time complexity should be O of mn because it might, in the worst case scenario, it might end up filling all of the grid, okay. So hopefully, like, this video was helpful for you. You can just keep following me. I'll just start producing these videos from now on. This is the flood fill, okay. Right now I'm just trying to strengthen my graph theory. So yeah, this is the code. I'll also push this code to GitHub so that it's easily accessible, and I'll also link down the GitHub repo link for this particular code so you can use it as a reference. I think I might have also created a my own solution for this one. Let's see. I can't. Let me visit my profile. Okay. Uh, so that I can just show you. Do we have that fill? Okay. Anyways, like I just link down my hash node article as well on this particular problem, as well as all of the code that I've written. Okay. And I think this might also be helpful. So I'll just link down this information as well. Okay. So it is easier for everyone to understand. So okay. Uh, Let me stop the recording now. And hopefully, this video was helpful. Okay, bye.